Daily. In this one we have 769 max chunks to make sorted. It says we're given an integer array of length n that represents a permutation of the integers in the range 0 to n minus 1. We split array into some number of chunks, aka partitions, and individually sort each chunk. After concatenating them, the result should equal to the sorted array. So basically, you have this array, you split it in different chunks, and you sort each chunk separately, and then the result should finally equal to the array itself being sorted, right? It needs return the largest number of chunks we can make to sort to the array. So basically, we want to split as much as possible, so as when we actually sort each chunk separately, we get and concatenate these sorts together, we get the whole array sorted, right? So for example, this is 43210. Splitting into two or more chunks will not return the required results. It tried splitting, it couldn't figure it out. So you could split it into 4, 3, and then sort this, so it's going to be 3, 4. 2, 1, 0 is going to be 0 and 2. So it's going to be in something like this. So it's not possible. That means the only chunk we can have is the main one, where we split the whole, where we sort the whole array. In this example, we can split into two chunks, 1, 0, where it goes 0, 1, and 2, 3, 4 is sorted already. Or another option which brings a higher level of chunks is 1, 0, and then 2, 3, 4 separately, right? When sorting each one. So this question, looking at the constraints of this question, the n maximum is going to be 10, right? So the number is definitely very, very small. So backtracking is an excellent candidate for solving this problem. So basically, in backtracking, what we're going to do is, for each index in the array, we can either choose one of two routes, right? We can either create a new chunk starting from this specific index, or append this index to the chunk, the previous chunk, like the last chunk in the array created, right? So you can either append it to the previous chunk, or just create a whole new one and start off fresh, right? We're gonna have to go through each option and figure out the maximum number of chunks where we can make the array sorted, right? So before going into the DFS on the backtracking logic, obviously I sorted the array first just to finalize, because I'm gonna check against it in this method here, which is called our chunks sorted. It just takes an array of chunks basically, and it just flattens them, right? And it counts the number of chunks if they exist. Sometimes there's just empty arrays, that's why I did this. It's probably not the cleanest code, but I mean it works. And then I extend the sorted chunk. So I sort the chunk and then I extend it to the flattened list. And then I'm just gonna return to a tuple of a boolean, where if the flattened lists equal the sorted version, which is this variable O up here, and the length of that flattened list, right? So in the DFS, basically, we're gonna have two parameters, right? I, which is the index that we're currently on, and chunks, which is the array we're currently working through, right? And we're gonna have this res, which is a global variable. I'm just gonna keep updating every time I find a higher number of chunks to get that sorted array, right? So first things first, we have the base condition. What's the base condition? If we reach the end, right? If we reach the end of the array, that means we finished the array, right? And we have an array of chunks of some sort. So I'm just gonna check, are these sorted? If they are, it's gonna give me the sorted chunks and the length of them, right? Sorry, it's gonna give me the sorted boolean and the length of that chunk, like array. And then if it's sorted, that means, all right, we actually found a chunk that's compatible. So I'm just gonna update the res, right, and return. Otherwise, I'm gonna return right away, because there's no point in moving forward because we finished the array, right? Now, time for decision making, right? So the first thing, I can either append, as I said, append the current index to the previous chunk, right? And then I'm gonna DFS my way. And then when I finish, I'm gonna backtrack. So what I'm gonna do is I'm gonna pop that number I added and then go the other way, right? What is the other way? Create a brand new chunk, right? This is creating a brand new chunk. I'm gonna DFS and then check it out, whatever. And then after that, I'm gonna pop that brand new chunk again. So this is backtracking essentially, where you actually go one way, maybe it works out, maybe it doesn't, but you track back and then you go a different way, right? So that's basically it. Running this will actually pass. The time complexity of this though, because we have two options for every number, so it's going to be 2 power n, where n is basically 10. So like maximum worst case, n is going to be 10. So it's going to be 2 power n in time complexity, because we have two options for every number. Yeah, so that's been it for this one. See you guys tomorrow.